For generations we have looked up at the night sky with a sense of wonder. We have built telescopes on mountaintops, peering through the veils of our own atmosphere to catch a glimpse of the universe beyond. Yet even our most powerful instruments on Earth are limited. But now we have an eye in the heavens themselves. It is called the James Webb Space Telescope. It drifts silently in the cold darkness of space far beyond our moon. This telescope is a marvel of human engineering, a golden honeycomb of mirrors, designed to capture the faintest, oldest light in the cosmos. It is a time machine in a very real sense. The purpose of this magnificent instrument is to look back to the very dawn of creation. It seeks the light from the first stars and galaxies that ignited after the Big Bang. This light has travelled for billions of years to reach us, stretched and reddened by the expansion of space itself. The Webb telescope is specially designed to see this ancient infrared light, a spectrum invisible to our own eyes. It allows us to witness the birth of worlds and the assembly of galaxies, revealing the story of our cosmic origins in breathtaking detail. A story we are only just beginning to read. Its journey into the cosmos was a triumph of collaboration, involving thousands of scientists and engineers from around the world. Launched on Christmas Day in 2021, it travelled 1 million miles from Earth to its final observation point. There it carefully unfolded its delicate sunshield and polished mirrors, a complex and flawless ballet performed in the vacuum of space. Not long ago, the telescope was pointed toward a familiar patch of sky. It was aimed at a region known to contain some of the most distant galaxies ever observed. Scientists were hoping to study the formation of these early cosmic structures in greater detail. They expected to see the faint red smudges of nascent galaxies, just as they had before. The initial data seemed ordinary, another thread in the grand tapestry of the early universe. The telescope gathered the ancient light, photon by photon, building an image of a time when the cosmos was less than 1 billion years old. But as the data was processed, something unusual began to emerge. Amidst the familiar shapes of primordial galaxies, there was an object that did not belong. It was a single point of light, but it behaved unlike anything else in the field of view. At first, it was dismissed as a possible glitch, perhaps an artifact from a cosmic ray hitting the detector, or a flaw in the imaging software. Such things are not uncommon in the complex world of space telemetry. The team ran diagnostics and recalibrated their instruments, expecting the anomaly to disappear upon a second look. However, the object remained. It was located near a well-known ancient galaxy, designated GNZ11, one of the oldest and most distant ever confirmed. This new object, now tentatively named GNZ11 Omega, appeared to be associated with it, yet it was profoundly different. It was not a star, it was not a galaxy, and it was not a black hole in the traditional sense. It was dark, almost perfectly so, but it was surrounded by a faint, rhythmic pulse of energy. A whisper from the void, a heartbeat in the dark, where there should have been only silence. The discovery sent a quiet, urgent ripple through the astronomical community. The data was checked and rechecked by different teams around the world. There was no error. The object was real. What makes this object so unusual, so deeply puzzling? It is a combination of things that together create a picture that is difficult to comprehend. First, there is its darkness. The object itself appears to absorb nearly all light that falls upon it, making it one of the darkest things ever observed. It is a void within a void. Yet this is not the signature of a supermassive black hole. Black holes are messy eaters. They are surrounded by brilliant accretion disks of superheated gas and dust, which shine brighter than entire galaxies as matter is torn apart before crossing the event horizon. GNZ11 Omega has no such accretion disk. It is clean, sharp and cold. The space around it is eerily empty. And then there is the pulse. The energy readings show a perfectly regular repeating signal emanating from the object's vicinity. It is not a random flicker of energy, but a structured metronomic beat. This pulse is incredibly faint, a mere whisper against the background noise of the cosmos, but its regularity is unmistakable. In nature, such perfect rhythm is rare. Pulsars, which are spinning neutron stars, have a regular beat, but their signal is vastly different in character and intensity. Furthermore, the object's size and mass are a profound contradiction. Based on its subtle gravitational influence on the nearby galaxy GNZ11, scientists have made a preliminary estimate of its mass. It appears to be as massive as a small galaxy, yet it is concentrated into a space that is remarkably compact. To have so much mass in such a small volume without collapsing into a black hole and producing a bright quasar is, according to our current understanding, impossible. It defies the known laws of physics that govern the life and death of massive cosmic structures. This is why some have used words like terrifying to describe it, but this is not a terror of monsters or aliens. It is the deep intellectual unease that comes from confronting a phenomenon that lies completely outside of our scientific framework. It is the feeling of looking at a piece of a puzzle that does not seem to belong to the same box. The object GNZ11 Omega is a scientific impossibility that is undeniably there. It challenges the very foundations of our understanding of the universe, and that is a truly humbling and awe-inspiring thought. The reaction within the scientific community has been one of cautious yet profound excitement. This is what scientists live for. It is the discovery that no one predicted, the observation that breaks the models and forces a complete re-evaluation of established theories. While the public might focus on the unsettling nature of the unknown, researchers see an unprecedented opportunity for discovery. Every major leap in our understanding of the cosmos has been preceded by a moment just like this one, when an observation simply does not fit. Newton's laws were born from planetary motions that needed explaining, just as relativity was born from the strange behavior of light. There is, of course, a palpable sense of concern, but it is a scientific concern. If our theories of gravity and galaxy formation are so fundamentally wrong that they cannot account for an object like GNZ11 Omega, what else are we missing? It suggests that our picture of the universe may be incomplete in a very significant way. Scientists are now poring over every detail, proposing new ideas and challenging old assumptions. The object has ignited a firestorm of discussion and debate in universities and research institutions across the globe, a collaborative effort to solve a puzzle presented to all of humanity. This discovery also brings a sense of humility. For all our progress, for all our powerful instruments, the universe remains a place of deep mystery. We have only been studying the cosmos with scientific rigor for a few centuries, a mere blink of an eye in cosmic time. To find something so strange so soon after deploying our most advanced telescope is a reminder that we have barely scratched the surface. It is a call to be more curious, more open-minded and more rigorous in our search for answers. The universe does not owe us simplicity or easy explanations. The excitement, then, is not just about the object itself, but about what it represents. It represents the frontier of knowledge. It is a locked door that we did not even know existed. Now the challenge is to find the key. As scientists grapple with this enigma, several possible explanations have been put forward, ranging from the exotic to the truly revolutionary. One of the leading naturalistic theories suggests we may be looking at a new type of celestial object, one predicted by some fringe theories, but never before observed. This could be a primordial black hole, not one formed from a collapsing star, but one that came into being during the first moments of the Big Bang itself. These hypothetical objects could have very different properties from their stellar mass cousins, perhaps explaining the lack of an accretion disk. Another possibility involves dark matter, the mysterious, invisible substance that is thought to make up about 85% of the matter in the universe. While we cannot see dark matter, we can detect its gravitational effects. Some theories propose that dark matter could, under extreme conditions in the early universe, collapse into dense, concentrated halos or dark stars. Such an object would be massive, dark, and could potentially explain the strange gravitational readings around GNZ11 Omega without violating the laws of physics as we know them. It would be the first direct evidence of a complex dark matter structure. A more speculative but still natural explanation is that we are witnessing a phenomenon from another dimension. String theory, for instance, posits the existence of extra dimensions of space beyond the three we experience. It is conceivable that we are seeing the gravitational shadow of a massive object from a nearby dimension, one whose light cannot reach us, but whose gravity can cross the dimensional barrier. This is, of course, highly conjectural, but in the face of such a strange discovery, even the most imaginative ideas are being considered by theoretical physicists. And then there is the explanation that lingers unspoken in the back of many minds. The perfect regularity of the pulse is the element that is most difficult to explain with natural phenomena. While it is a leap that no scientist would make lightly, the possibility that the signal is artificial cannot be entirely dismissed. This does not necessarily mean little green men. It could be a beacon, a probe, or some form of ancient technology from a civilization long vanished. This idea is treated with extreme caution, as extraordinary claims require extraordinary evidence. For now it remains the most unlikely, but also the most profound possibility of all. The discovery of GNZ 11 Omega is not an end, but a beginning. It has provided the scientific community with a clear, singular target for future investigation. The immediate plan is to dedicate more of the James Webb Space Telescope's valuable observation time to this one enigmatic point in the sky. Scientists will conduct a deep-field observation, allowing the telescope to stare at the object for hundreds of hours continuously. This will allow them to collect more light, to build a more detailed picture, and to study the faint rhythmic pulse with much greater precision, hoping to find more complexity within the signal. Beyond James Webb, other instruments will be brought to bear on the mystery. Radio telescopes on Earth, such as the Atacama Large Millimeter Array in Chile and the Future Square Kilometer Array, will be turned towards that patch of sky. While the object itself is dark, they will search for any faint radio waves that might be associated with it or the strange pulse. Different types of telescopes see the universe in different ways, and a multi-wavelength approach is our best hope for building a complete picture of what GNZ 11 Omega truly is. It's like using sight, hearing and touch to identify an object in a dark room. The theoretical work will proceed in parallel with these new observations. Physicists and astrophysicists are already running complex computer simulations. They are testing whether new models of dark matter, modified theories of gravity, or other exotic concepts could produce an object with the observed properties of GNZ 11 Omega. Each new piece of observational data will help to constrain these theories, ruling some out and lending support to others. It is a slow and meticulous process, a careful dance between theory and observation that will gradually close in on the truth. In the long term, this discovery will undoubtedly influence the design of future space telescopes. If objects like this exist, we will need new instruments specifically designed to find and study them. Future missions may be developed with capabilities tailored to detecting extremely dark objects or analyzing faint, structured signals from the depths of space. GNZ 11 Omega has opened a new window into the cosmos, and future generations of astronomers will be building the tools needed to look through it more clearly, continuing the journey that James Webb has so wonderfully advanced. There is a profound silence in space. It is a vast, cold emptiness that stretches for unimaginable distances. For all our searching, for all our listening, that silence has been the defining characteristic of the cosmos. We have found planets, stars and galaxies in their billions. We have found chaos and order, beauty and violence, but we have always found nature. The universe, as far as we knew, was magnificently, beautifully and perhaps terrifyingly indifferent. It followed its own physical laws, playing out a grand cosmic drama without an audience. Then came this signal, a tiny rhythmic beat from the edge of time. It is so faint, so ancient that it is almost nothing. But it is not nothing, it is a pattern, and patterns have meaning. In all of human experience, from the beating of our own hearts to the intricate designs of our art and technology, complex repeating patterns are a hallmark of either life or intelligence. Nature can produce rhythms, certainly, the spin of a pulsar, the orbit of a planet, but the specific characteristics of the pulse from GNZ 11 Omega seem to stand apart from these. This is where the suspense builds, not with fear but with a deep sense of anticipation. We are standing at a threshold. We have detected something that pushes the boundaries of our understanding. The silence of the universe has been punctuated by a single, mysterious note. Is it a natural phenomenon so rare that we have never conceived of it before? Or is it something else? Is it a message in a bottle thrown into the cosmic ocean billions of years ago, finally washing up on our shore? We do not know. And not knowing is the most exciting state for a curious mind to be in. The facts slowly accumulate, each one adding another layer to the mystery. Its darkness, its impossible mass, its compact size, and its perfect rhythmic pulse. Each fact deepens the puzzle. We are like detectives who have found a single, inexplicable clue at the scene of a cosmic event. We must now proceed with patience and care, gathering more evidence before we dare to draw any conclusions. The universe has asked us a question, and the quiet, thrilling work of finding the answer has now begun for all of humanity. This discovery, whatever its ultimate explanation, changes our perspective. It reminds us that the universe is not just old and vast, but that it is likely more complex and stranger than we have ever imagined. It reinforces the idea that we are explorers in an undiscovered country, and that the map is still largely blank. Far from making us feel small or insignificant, this realization can be a source of great inspiration. It gives us a grand purpose to continue to explore, to learn, and to understand our place in this magnificent cosmos. The quest for knowledge is one of the noblest of human endeavors. It is driven by curiosity, a trait we all share. It is this innate desire to know what lies over the next hill or beyond the next star that has propelled our species forward. The James Webb Space Telescope and its discoveries are the modern expression of that ancient urge. It is a story of hope, a testament to what we can achieve when we work together to pursue a common, peaceful goal. The answers we find in the stars ultimately teach us more about ourselves. Whether GNZ 11 Omega turns out to be a new kind of star, a quirk of dark matter, or something completely unforeseen, its discovery has already succeeded. It has sparked the imagination of millions, united scientists in a common cause, and reminded us of the profound beauty of mystery. The journey to understand it will undoubtedly lead to new technologies, new theories, and a deeper appreciation for the universe we call home. The path ahead is long and challenging, but it is a path lit by the star of human curiosity, and that is a light that will never be extinguished. The story of the cosmos is still being written, and we have the privilege of reading its earliest pages. Thank you for joining us on this journey. If you found this exploration of the unknown as fascinating as we do, please consider liking this video and subscribing to Cosmic Discover for more stories from the frontiers of science. We will continue to follow the investigation into this incredible object and bring you updates as they happen. The universe is speaking, and we are learning how to listen.